G'day, in this video I'm going to show you one of the best practices that we recommend to all of our clients. It has the greatest return on investment, also lowers input cost. So it's a simple and easy thing to do as well as cost effective, and that is seed treatments. So today in this video we'll be talking about our fungicide seed treatment compared to what we do, which is a nutritional and a biological seed treatment. And we're going to be talking about how they compare so you can make an informed decision. Now, I talk about fungicides and more or less in a negative light in this video. It's important to know if you need to use a fungicide, do it. There's no need to be dogmatic about the practices we use. If you have a massive disease burden and you have to, then that's fine. However, what we like to do is a nutritional and biological approach, as well as cultural approaches to reduce that disease burden and improve our plant defense mechanisms to resist against different diseases. So in this video, we'll be talking about a wheat crop with a yield target of around 4 tonnes a hectare. So with that, we'll have a seeding rate of 84 kilos a hectare. So use those numbers, compare them to your own numbers, say what fungicide you use and how much that costs and what you could potentially do with this. Now I'll be breaking down the costs of all of this so we can directly compare what a nutritional approach compares to a fungicide approach. Now of course there's a whole range of different fungicides, so take this number, compare it to your own, it doesn't quite matter. We'll be talking about the general ideas of how these affect each other. So let's start off with the fungicide. A fungicide, typically, if you do apply as a seed coat, the aim of the fungicide is to prevent the attack of different pathogens on the seed and on the seedling. So after about 4 to 6 weeks, the fungicide is more or less ineffective. It could have a mild suppressant effect on those particular diseases. Mainly fungal diseases. So I'm not going to say exactly what fungicide these numbers are from, but if you do your research, I'm sure you could probably find something similar. You could buy it for about $545 for a 10 litre bottle. It contains 3 different active ingredients, so something from group 3, 4 and 7, and the recommended application rate is about 2.7 litres a hectare. So that's going to cost you to do your hectare about $12.05 a hectare. And that will give you the benefit of suppressing these diseases. So that's good, you get a disease suppression effect, which is good because that's what you pay for. Now, there is a slight problem with fungicides, and that is a resistant build-up to that particular fungicide by our pathogens. So if you're constantly using the same fungicide or the same active ingredients in the fungicide, then there's a greater and greater chance that your fungicide is going to be less effective over time. So you want to alternate between them. However, the big problem with fungicides and a lot of the sides, so pesticides, herbicides, fungicides, bactericides, is that they are a toxin, they are a poison, and they will poison the plant. Even though this is not quite an active ingredient that targets the plant, it still has a damaging effect on the plant and the microbiome around it. And even though it technically doesn't affect us, it still is suspected to cause cancer. On the label, if it says it's damaging to us, then it's most likely also damaging to our plants and the microbes around it, which is very critical for its growth. So from what I found, there's 3 main negative impacts that fungicides have on the plant. The microbes, the first one is that it suppresses microbes. So that doesn't necessarily mean it's going to kill all the microbes, but what it does mean is that you'll have a suppression in the activity of those microbes, as well as the colonization of, say, mycorrhizal fungi. So it won't completely wipe out, or most of the time, it won't completely wipe out the mycorrhizal fungi population, but it will definitely suppress them and prevent them from developing symbiotic relationships with the plant. And so if you think about it over here, when we have this fungicide around the seed coat, when our first root comes out, that's still going to be covered in the fungicide. The mycorrhizal fungi aren't going to like that, they're not going to colonize, which means we're going to lose all the benefits that it brings, the phosphorus uptake, the zinc uptake, a whole range of different minerals, as well as water. So we're really handicapping our plants by not allowing them to form these symbiotic relationships with our microbes. And we know wheat is very reliant on mycorrhizal fungi, as well as a whole range of different microbes that assist in the plant's development. So from what I found looking at different studies, different fungicides and their active ingredients have different effects on microbes. So it doesn't necessarily mean that you're going to get a reduction in a microbial activity. Some actually increase the population, some increase the activity. Not sure about the long-term implications of that, but overall, it seems that there's a suppression effect, even though you don't kill the microbes, in general, you get a suppression of microbes. And this is super important because the more and more we understand about microbes, the more and more we understand that it's fundamental for our plants to form these symbiotic relationships with our plants to get a healthy plant. So overall, in a lot of the studies I looked at, it reduced root development as well as plant development. So overall, really staying the plant, and I would assume this is because the plant then needs to put all this effort into detoxifying itself from the fungicide before it can actually contribute to growing. Likewise, it suppresses the microbes, and microbes are also important for plant development. So when you get these two hits to our plant growth, it's likely to really affect it. So the next one I found is a reduction in germination rate and speed. And so you'll see it here in this graph, the germination rate dropped. So by day 29, the no fungicide seed treatment had, I think it was 80%, just a bit above 80. And the fungicide treated seeds had a germination rate of around 70, or just above 70. So there's a 10% in terms of absolute numbers difference between the germination rates. Now if you think about that in terms of buying seed, 10% of the seeds you buy aren't going to germinate if you apply a fungicide. So that's going to add up and it's going to be quite expensive. That's going to be additional 8.5 kilos a hectare. You have to carry that around, transport it, you have to go back sooner. You could effectively reduce your seeding rate and still get the same number of plants to come up. Now the other thing you notice in that graph is that the untreated seeds came up faster. So about 65% was germinated at day 13 compared to, I think it's 14% of the fungicide seeded trees were germinated by day 13. So there's a massive spread on that. As soon as the plant gets up and going, it can then start photosynthesizing. It can then continue to form these symbiotic relationships with our plant. We know at the third leaf stage that determines the amount of tillers and spikes, or the spikes, spikelets, and number of grains per spikelet. So all of this will be really affecting that first critical point of influence on our plant. And if you don't know what that is, go check it out in this video. It'll explain everything you need to know about the different stages you need to hit to maximize your yield. Now the big thing I noticed is that the fungicide required that full 29 days to even catch up with the first 13 days of our untreated seed treatment. And so effectively the untreated seeds were 16 days ahead of the fungicide treated seeds. So think about what a week and a bit can do. Massive difference in the effect that will have on our yield and the resilience of our crop. So overall, I would say that in the absence of disease, now this is important because in the presence of disease, it's probably going to be the other way around. In the absence of disease, the untreated plant will always win. It doesn't need to detox itself of these chemicals. However, if there is a disease problem, you're probably better going with the fungicide. At least you're going to get some plants up. They might be stunted, but at least they're not going to be suffering from disease. However, I would say if there is a disease problem, while you're planting wheat back into there, why don't you have another crop in your crop rotation to then break the disease cycle? Or plant a cover crop for a year, and you might not get maximum yields out of that or the same profit per hectare, but you can graze it out, recoup some of that loss, fix some nitrogen, stimulate microbes. There is a disease suppression effect when you have lots of different species because of competition. But anyways, all of that, the last 4 to 6 weeks, so not even the whole life cycle of the plant, and we'll get that for $12.05. Now I'm going to formulate what we would recommend to our clients, including the different products we recommend. And the first one is trace minerals. So we can apply a trace mineral coat or product to our seeds. Now this will give a really good kickstart, have all the available nutrients it needs. Now this is really beneficial. It's only a very small amount of trace minerals, so it's quite cost effective compared to applying it as, say, a foliar even 2 weeks later. And that's because you're applying just a small amount to the seed. It's very targeted, so basically all of it is available to the plant, and it will correct any deficiencies that you have in the soil. Very useful for trace minerals, getting them right onto the seed coat. You're not so much affected as much by the soil environment. So say, for example, if it's an oxidizing soil environment, a lot of the trace minerals will drop out of availability. Applying it to the seed, some of that can be internalized by the seed and utilized, others on the outside of the seed coat, but it's more protected there than if you add it with your starter fertilizer. So this is quite well known with zinc. Zinc is a really good example of that. Now the application of zinc as a seed treatment is pretty well studied. There's an increase in growth and development that comes along with it. Zinc is required in the leaf size. So making sure we have sufficient amount of zinc is important, so we have a bigger leaf size, and so more photosynthesis. More photosynthesis leads to everything required for plant growth and development. Now, making sure we have basically a broad spectrum of trace minerals is important to get all the benefits we need. And more about the trace minerals, we have all our videos on the different minerals required for plants. But here are the trace minerals we add in our seed treatments. So we have nitrogen, phosphorus, potassium, sulfur, calcium, boron, zinc, copper, manganese, iron, cobalt, and molybdenum. All of them super important for the plant to just grow and develop. We get so many disease suppression effects from a lot of our trace minerals. A lot of these can be locked up in the soil and unavailable to our plants. So making sure we apply it to our seed in a chelated form with fulvic acid, and we'll get to that in a moment, really gives that plant the nutrition required to get up and going as soon as possible. Now, with all our trace minerals, we also apply kelp, fish, and fulvic acid. Now, this is almost the carbon component or the food component to this. This will help with the more or less the stimulation of the plant to grow, as well as our microbes that are already present in our soil to really get going, repopulate, and form symbiotic relationships with our seed. So that's important for things like the rhizophagy cycle, as well as any disease suppression effect we get from our plants, as well as increasing the availability of other nutrients. And so kelp is the first one. Kelp has a wide range of different minerals. So in addition to all of these, there's also things like iodine, which is really important for the plant. Kelp will have that in it, as well as a lot of plant hormones and autoinducers. So one specifically important is the cytokines. They stimulate root development and cell elongation and cell division. So it's very important in this stage where we have a differentiation of different cells forming that root, forming everything else in the plant. It's also important for the elongation of that root. So we want to get a really long root as possible deep into the soil, because that's going to give the plant the best ability to access different, more water as well as different nutrients as we go deeper into the soil profile. Likewise, when it starts to dry off, plants are required to go deeper and deeper down into the subsoil. So making sure we have that really strong and robust root will give us the best chance of maximizing our yields. So one study found where they're using kelp or seaweed as a seed treatment, they increased root development or length by 20%. They also increased the above ground biomass by 25% when compared to not having kelp. So kelp, obviously having a 25% increase in our above ground biomass and a 20% increase in our root length, super beneficial for fixing more carbon and then sequestering that into the ground, feed the microbes, and the whole system is improved with that. The next thing we add is fish. Fish has a whole range of different amino acids and proteins that become available to the plant. These are better forms of nitrogen than, say, nitrate and ammonium. There's less energy required for the plant to take them up and then convert them into proteins. If we're only going from amino acids to proteins, there's less energy required to do that than, say, if we had nitrate and then you have to follow that all the way along into proteins. Now, the fish also stimulates the microbes in the soil around it, furthering that beneficial effect we get from all our microbes, so the rhizophagy cycle and all that, which is also going to then deliver nutrients to our plant. Now, finally, we have our fulvic acid. Fulvic acid is a humic substance. This is really beneficial for increasing bacteria populations because it's quite a small size and it is perfect food for bacteria. Increasing our bacteria populations in our soil is actually quite beneficial, even though when you think of that bacteria-fungi ratio, in general, the better your microbial populations, the better regardless of the ratio. And fulvic acid helps to stimulate the bacteria. Now, bacteria are quite important still because they participate quite strongly in the rhizophagy cycle, and we have a video on that, so you can go check that out. But that delivers so many nutrients to our plants, especially calcium, which is quite important for all our critical points of influence. But the other thing that fulvic acid can do is chelate our minerals, especially our trace minerals, increasing the availability of those into our plant. And it also increases the uptake of different minerals by making the root more permeable to our minerals. So in our consulting, we recommend this product to our clients to add as a seed treatment. This is the lowest hanging fruit you can do. One-time application at the start, doesn't change really anything else you do. You still sow the same. All you got to do is apply it beforehand as things are going up. And you can see the product on our website, but basically we're going to be applying this at a 4 litres per tonne of seed, which means on a per hectare basis, that's going to cost approximately $2.62. So pretty cheap compared. Now we have a whole range of other things that we're going to get to, but to get that starter nutrition on for $2.62 a hectare, fantastic return on investment on that. When you think about getting 20% increase to your root length and a 25% increase to your canopy cover, fantastic return. So they kind of cover the nutritional components. So nutrition to both our plants and our microbes to get everything going. Now we're going to be talking more about the biological components, specific bacteria and fungi that we can add to our plants to get increase in nutrient availability and defense for our plant. So the next component we add to our biological seed treatment is worm castings. Worm castings hold a very wide range of different bacteria and fungi and protozoa, all of which is super important for contributing different traits to our soil and our plant. Now you can produce your own worm castings at home and then extract the worm casting extracts from that. Now, it's important to clarify the leachate, so the water that you get after you pour water onto your into your bin, for example, and comes out the other side, that doesn't contain all the good stuff. So that's not the good stuff. The good stuff is when you take your worm castings and you basically put it through an agitator, or not through an agitator, but you agitate the worm castings in water, and you really beat off all the microbes and the autoinducers and the hormones off the worm castings. And so there's a 10 times in beneficial bacteria and microbes when you use an extract rather than a leachate. Super important that you do that. But you can produce this at home relatively cheaply. It's quite easy to do and you get amazing returns on that. Now the worm castings, as I said, hold a very wide range of different bacteria. And those bacteria are going to have a range of different functions in our soil. So the biggest one is nitrogen fixation. There's a whole range of different bacteria that will fix nitrogen in a free living sense. So they don't need to form symbiotic relationships like legumes and rhizobium bacteria. They are free living. They eat the root extracts from our plants and then produce their own nitrogen. So the nitrogen that they do produce is in small amounts, but anything is quite beneficial. So if it's 10 to 20 kilos a hectare, that's free nitrogen that you didn't need to buy. There's other bacteria that will solubilize phosphorus, so free phosphorus. Now, we tend to have a lot of fixed phosphorus in our soil. If you've had a really good fertiliser routine and you're applying a lot of super, adding your worm castings and that phosphorus solubilizing bacteria will actually release a lot of that stored phosphorus in your soil. There's other microbes as well that suppress different pathogens in our soil. There's a study here that you'll be able to look through and find all the different microbes in worm castings and how they contribute to plant growth. On that, they actually increase plant growth, so there's a lot of plant growth promoting bacteria in our worm castings. Worm castings, as I said, a very wide range of different bacteria, fungi and protozoa. Protozoa are quite useful because they graze on our bacteria and then cycle nutrients. So adding all that onto our seed coat allow for a whole diverse range of microbes to be on our root zone, which allows for a very quick development of the rhizosphere and the rhizosheaths you'll find around the plant. We really want those because that is telling us that our plants are forming symbiotic relationships with our microbes. When we see root hairs, that means that our plant's participating in the rhizophagy cycle, all of which is super important for us to get free nutrients for our plants, which saves us a lot of money as farmers. Now the product we recommend applying that at 2 litres per hectare, per tonne, which is going to cost us about $1.39. So not bad to get all the microbes straight into your seed and firing from the get-go. As I said, you'll find that your soils will be functioning a lot better with a worm casting product. Either produce your own or trial a different range of different growers. We found a supplier that we really like all their products, so that's why we partner with them. But you can do it for free by growing it yourself, or you can find cheaper alternatives. But overall, you're going to get an increase in plant biomass, root development, nutrient cycling to your plant, a whole range of different benefits. If you were to only apply one thing, I would suggest worm castings, super beneficial, because it's in the worm castings that you do get a little bit of nutrition, but the real benefit is the diversity you get from your microbes, and it beats everything for such a small amount of money. So the next group I'd recommend for this is our plant defense microbes. So these are things like Trichoderma, Bacillus, and Streptomyces. These things basically replace the need for fungicides because these have they have a disease suppressive effect, and we'll go over them now. But basically, we have a product or use a product that contains each of these in the one product. But you can grow your own Trichoderma, you can grow your own Bacillus. I'm pretty sure you can grow your own Streptomyces, or you can buy it in different products. I would probably suggest buying them first and inoculating them, just inoculating your seeds using a commercial product, just to see how it goes. And if you were thinking of brewing or growing your own, continue to use the commercial product and then slowly introduce your own, just because you might not have the process down pat when you're growing your own. So it's good to know it actually works on your farm using a commercial product, because there's certain quality control mechanisms at play with that, just to see if it works. If it doesn't work on your farm, then maybe try different other products, but there's no point going through all the effort, because it is a lot more effort to be making your own than just simply buy it in. So buy it in, then start making your own. So that's what we would recommend. But anyway, Trichoderma. Trichoderma is a predatory fungi and has two modes of actions when controlling different pests. The first one is that it itself is a predator and will prey on different microbes. So it will prey on both pathogens as well as all of our other microbes, which is not a bad thing because it releases nutrients to our plant. But in terms of controlling pathogens, it will prey on different soil-borne pathogens as well as airborne diseases. So things like rust. Seed treatment of Trichoderma actually contributes to the control of a whole wide range of different pathogens, the whole life cycle of the crop. So unlike our fungicide seed treatment, which only lasts 4 to 6 weeks, the Trichoderma, because it's a living thing, can replace itself for the whole crop cycle. So the application, the seed application, will actually contribute to way down further in the track when you're about to harvest, and you're making sure you want to maintain your flag leaf integrity. Trichoderma is a really good option to suppress disease for the whole crop cycle with a simple seed application. So that was one mode of action, which is the predator aspect of the Trichoderma. But it's suggested that just as much of the disease suppressive ability of Trichoderma is contributed by the Trichoderma stimulating the plant's induced systemic resistance to different pathogens. So that's just a fancy way of saying it upregulates the plant defense mechanisms. It allows the plant to produce more and more defense compounds. So that is the two main actions of that. Same with Bacillus. Bacillus is not so much a predator, but it produces antifungal and antimicrobial properties for pathogens, as well as stimulates the plant's immune system, and same with Streptomyces. So all of these create a synergistic effect when used together. It stimulates the plant defense mechanisms and contributes to overall plant health. If you're interested more about Trichoderma, I've linked a study that explains all of this. It'll be in the supplementary material for this video on our website, so go check it out, because we have basically all this written up, as well as links to the products we use. The other thing about Trichoderma is that there's also an increase in nutrient cycling when you use it. So a whole range of different beneficial things you get from Trichoderma. Likewise with Bacillus and Streptomyces, they increase the availability of a whole range of different minerals, and there will be links to the benefits of each of these also in the supplementary material. Now finally, a very big benefit that you get from the application of these biological components is that you get a wide range of protection against a whole range of different pathogens. So unlike the fungicide, which only affects or only suppresses a certain amount of diseases, according to the active ingredient or the mechanisms of which that controls different pathogens, there's only maybe 4 or 5 different pathogens it can control. Now, with a combination of different microbes as well as the nutrition and all that, it can control a wider range of different pathogens, because the mechanisms are broad. Like trichoderma as a predator doesn't really care what it's going to eat. It's going to eat everything. So I think in one study we could control up to 30 different diseases. Now I'm sure different diseases it can control better than others, but overall you're going to get a wide range. Chance that later in the season you won't even need to apply a fungicide for rust because your trichoderma and all your other microbes are going to be controlling it. Likewise with this is going to control, say, a certain root rot. Later you have to apply another fungicide for rust. 2 applications, you can do it for 1 with trichoderma. You might need to top up with trichoderma later in the season and you can follow apply that. But overall, this is a really good option for that. So we recommend applying this. As I said, we have a product that contains all of that at 1 litre per tonne of seed. Now you're probably thinking, wow, for all those benefits, it's probably going to cost me $1 bazillion. It only actually costs $1.39. Nope, sorry, it's wrong. It's actually 38 cents. There you go, I just saved you a cent. Now, I would say at a bare minimum, applying each of these 3 things would get you 90% of the benefit. Now, if you were to apply each of these, that's going to cost effectively $5.39 per hectare. And that's going to produce a lot of benefits. You're going to get that nutrition, getting that seedling up and going, and you're going to have the worm castings to produce a whole wide range of different microbes onto your seed, which will contribute a whole range of different functions, from disease suppression to increasing nutrient availability, as well as supplying your plant with a whole wide range of different health growth promoting benefits, and a replacement for our fungicides through biological fungicides effectively. It's only going to cost you $5.39. Now, we kind of start with this. This is a minimum that we would suggest applying as a seed coat. Now, you can do an additional seed coat of mycorrhizal fungi. The only problem with this is that it's a lot more expensive. So it's $7 per hectare. Depending on your application rate, you can do anything from 50 grams to 500 grams a ton. So that's ranging from what, $7 a hectare to $70 a hectare. So a wide range, a lot more expensive. The other thing about mycorrhizal fungi is that it's likely to be in your soil if you've done a mycorrhizal inoculation before. So overall, there's a good chance it's already in your soil. However, there's a good chance as well that it's really reduced in population after a fallow. So after 2 weeks of no living roots, your mycorrhizal fungi population will start to die off. So after all the summer where you don't have any plants growing, or even towards the end of your crop growing as it senesces and you're ready to harvest, there is no root extracts coming from your plants. So really, there's going to be a few months of no food for your mycorrhizal fungi if you don't have a cover crop. Having a cover crop extends that, increases your mycorrhizal fungi population numbers, which means you don't really need to be applying an inoculant. But if you're really trying to, say, stimulate all of this, you can. As I said, it's $7 at the minimum. It's $7 a hectare. But you get massive returns on investment for that still. The mycorrhizal fungi, as we all know, form symbiotic relationships with our plant. So it actually joins into the plant, not just on the outside, but in the plant root, and extends the root zone a lot further. I think it can be up to 1/2 meter of additional root zone. So it's quite a big increase in the area that the plant can then find nutrients and water in. So scavenging things like phosphorus and zinc, as well as nitrogen. So the mycorrhizal fungi form a symbiotic relation with the plant as well as its own bacteria. So on the end of the mycorrhizal fungi hyphae, there's actually other microbes that it has relationships with, which can then produce its own nitrogen to feed back to the plant. Likewise, mycorrhizal fungi hyphae are small enough to fit into small areas in a aggregate, accessing more water for the plant. Mycorrhizal fungi also stimulate plant development through production of different compounds. There's a good chance when you use the inoculant, you'll be increasing the colonization rate of your plant. So you're going to get a more robust mycorrhizal fungi population versus if you left it up to the existing population to inoculate it. So I would really recommend a mycorrhizal fungi inoculant if you had, say, a long fallow or after a brassica crop. Now, brassicas don't form symbiotic relationships with mycorrhizal fungi. Actually, they kind of do. They can tap into it, but they don't feed the mycorrhizal fungi. So after a brassica crop, your mycorrhizal fungi population is probably down. So an inoculant of this after Longfellow or brassicas, really good. Otherwise, if you're really trying to maximize production, just apply this anyways. It's $7 a hectare. You also get a synergistic effect with your defense organisms. So there's one study, and you'll see it here, where the application of both mycorrhizal fungi and trichoderma produced a greater effect of disease suppression on rust than if you would just have one or the other. So your $7 here effectively increases the efficiency of everything else, as you can increase the uptake of these minerals, form better relationships with your different bacteria, increases the effect that you're going to get from trichoderma. Mycorrhizal fungi, super important, very beneficial, but at a bare minimum, applying everything else for your $5.39 is good. But if we would have the El Primo seed treatment, we would include that for effectively the price of $12.39 per hectare. So that is including the mycorrhizal fungi, and we'll get lots of benefits from that. Now, when we compare this $12.39 to your $12.05, it's more or less the same. Your biological and nutrition approach is going to be 2.8% more costly than your fungus, or this particular fungicide treatment. That's going to change depending on, firstly, your prices for this. If you're doing it at home, it's going to be a lot cheaper. If you're buying it in commercially, your products are going to vary in cost and whatnot. That's what ours costs with the current pricing. And as I said, you're going to get all these benefits, a whole wide range of different benefits. You're going to increase your nutrients, you're going to increase your root development, your above ground biomass, very important. You're going to be adding different biology to it, which has a different range of functions in itself. Trichoderma, Bacillus, Streptomyces is basically a replacement for your fungicides. And then to tie it all up together and really enhance all of that is the mycorrhizal fungi. And we know just how important that is. A final thing to mention is that I wouldn't recommend crossing both of these. I wouldn't apply a fungicide and a nutrition and biological approach, because you suppress the microbial component, and majority of this is microbial in nature. Likewise, I think a lot of fungicides actually lock up minerals, so there's no point in applying your minerals to your fungicide, because it's just going to lock it up anyways. So some take-home notes for you if you're thinking of trying this. Firstly, sign up to our consulting program. We can help you implement all of this. But if you want to do it by yourself, what we would recommend, and this is what we recommend initially to clients, is that if they have a program of using fungicides, just don't change it. Get your worst paddock, because effectively there's a lower risk, like business risk, if you use your worst paddock to trial things on rather than your best paddock. Use your worst paddock, add a seed treatment, and see how it goes relative to everything else and the past performance of that worst paddock. Even if you don't want to use your worst paddock, use half your worst paddock. Trial, do a direct comparison. How did my fungicide treatment go compared to my nutrition and biology? We've done that on some small plots, so you can see some of the photos here. The seed treatment had much darker color in the leaf. The plant was bigger, the roots were bigger. Everything was better about this plant compared to, it wasn't with a fungicide, sorry, it was with a no seed treatment. So it was just control versus a biological nutrition approach. So much better results in just biomass. And if you're producing a crop for forage, this also is beneficial. You're going to have an increase in nutrient density in your plant because you're relying on microbes to supply your nutrition. So there you go. For the El Primo inoculant, get it for $12.39. Comparable to your fungicide. In a lot of cases, it's just as good as your fungicide, but you get so many more benefits. You get an increase in yield because you're applying all these different minerals and plant promoting benefits. So when you think about regenerative agriculture, you should be thinking about this, that it's just as productive, if not more productive and cheaper than, say, a conventional approach. If you want to get started with this, reach out. We have a free consultation. Otherwise, you can jump straight into our consulting services. Thanks again for watching. My name's Till Simmons. Cheers.